So in this lecture, I want to talk about finding the volume of a specific kind of solid, what's called a solid of revolution. Right? And the way we create one of these things is we start with a continuous function f, and we define the region R to be the region bounded by the graph of f. So for my example, that's going to be this curve here, the x-axis, and 2 points, x equals a and x equals b. What we're going to do to make this solid is we're going to take this area and we're going to revolve it around the x-axis. So we're going to spin it through here. I'm just kind of picking out some points here so you can see the general idea what this shape is going to look like. And what we end up with is this kind of solid figure, right? And this is what we mean by a solid of revolution. It's the volume carved out by that region R as we spin it around the x-axis. And I want to find the volume of this thing. And I'm going to do this using our method of slices. I mean, that says that the volume is equal to the integral from a to b of a of x dx. All right, so what's a of x? Well, if you look at my diagram over here, right, because we created this figure by taking every point on the graph and spinning it around the x-axis, every one of these cross sections is a circle. Right? So if we let y, well, let's start with x, right? We'll pick a point x here. The radius at that point is y. It's the height of the function. So a of x is equal to pi times y squared. There's the area of a cross section. Right, but we started off talking in terms of f, right? So let's write this that way. I'm going to say this is pi times f of x squared. Right, let's substitute that into my volume formula over here. This is the integral from a to b of pi times f of x squared dx. And that's it. Right? That's my formula for finding the volume of a solid of revolution. So this is our formula. I've just cleaned it up a little. I've pulled the pi out in front. Right? And this has a name, right? It's called the disk method. Right? And if you look back at the diagram, those parallel cross sections, they look like disks. Right? So this is where the name comes from. We're going to take this and we're going to look at some specific examples of how we can use this formula to find the area of some solids.